Hi guys, I'm Nancy, and I'm going to show you how to find the domain of any function. The domain is kind of an annoying question that you'll get about a function, but it can be very simple. And all it means is all possible x values that you can have in your function. So all allowable x values that you can have in your function. To do this, you should already know how to solve a quadratic by factoring and how to solve an inequality. Okay, so these are the 5 types of functions you might have to find the domain for. I'm going to go through all of them. If you want to skip ahead, you can. Just look down below in the description for the time to skip to. The first case is really easy. If you have a polynomial, just an x expression, like x squared plus 3x plus 1, no square roots, no fractions, your domain answer is just all real numbers. And you can write that phrase, all real numbers, or you can write interval notation, parentheses, negative infinity, comma, infinity, and parentheses. Now, if you don't have just a polynomial and you have something more complicated like a fraction or a square root or possibly both, it's going to be one of these 4 cases. It's either just a fraction, it's a square root on its own, it could be a fraction with a square root in the bottom, or a fraction with a square root in the top, the numerator, and I'm going to explain how to find the domain for all of those cases. Okay, say you have just a fraction. To find the domain, all you have to do is take the bottom, whatever that may be, and set it not equal to 0. So in this example, we have x squared plus 5x plus 6 not equal to 0. Notice that it doesn't matter what the top is, just take the bottom and set it not equal to 0. And you can solve this just as if it were a normal equality, and that involves factoring. If you need help with factoring or solving by factoring, you can look at one of my other videos. So in this equation, we get 2 restrictions, 2 solutions. X cannot equal negative 3, and x cannot equal negative 2. So when we want to write the domain, the final answer for domain, you can write it as all real numbers, but x cannot equal negative 3 and cannot equal negative 2. Or you can use interval notation and write it as everything from negative infinity all the way up to negative 3, not including negative 3, combined with everything from negative 3 to negative 2, not inclusive of either number, combined with everything from negative 2 all the way up to infinity. So either of these notations is fine, they mean the same thing. Let's look at another example. What if you're given something like this, where the denominator is x squared plus 3? Same thing, take the bottom, set it not equal to 0, because we cannot have the denominator equal to 0. It's not defined when it is. Now when you solve this equation, you end up with x squared cannot equal negative 3. But x squared can never equal negative 3, so we just can't have that ever. There's no x value that would ever make that happen, so you don't need to worry about that restriction. All you need to write in that case would just be your normal all real numbers domain. So you can say all real numbers. You could say capital R symbol for all real numbers, or you could say with interval notation everything from negative infinity to positive infinity. with parentheses on either side. So that would be your three ways of writing the domain for this fraction. Now let me show you what to do if you have just a square root in your function. I'm going to focus on a square root, but this is true for any even root, a fourth root, sixth root, etc. It's not true for odd roots like third root. If you have a square root or an even root, you take the expression underneath the radical sign, which is the radicand, everything that's underneath the root symbol, so in this case x plus 1, and you need it to be greater than or equal to 0, because we can't have a negative number underneath a root. You can only have a positive number or 0. So what's underneath must be greater than or equal to 0. Now you're going to solve that normally, as you would solve any inequality. And you get the restriction x is greater than or equal to -1. So your domain would be all real numbers x greater than or equal to -1. Or you can write it in interval notation as everything from -1 all the way up to infinity. Notice that I used a square bracket for -1 because we're including -1, and everything all the way up to infinity, parentheses. So either of these ways is fine as notation for the domain. Okay, let me show you quickly also an example with a quadratic expression under the root. So here we have x squared plus 5x plus 6 underneath a square root symbol. You still do just take the expression underneath the root symbol and require that it be greater than or equal to 0. Okay, you need to solve this inequality. It's a quadratic inequality, which is more complicated than the last example. If you don't know how to solve that, you can look it up somewhere else. But once you have solved this quadratic inequality, you will get that x can be less than or equal to -3, or x can be greater than or equal to -2. So your domain, you can write either as all real numbers, but x less than or equal to -3, x greater than or equal to -2. If you were going to write this in interval notation, it would look like everything from -infinity all the way up to -3, including -3, and everything from -2 all the way to positive infinity. So either of those ways are fine to write your domain answer. Okay, if you have a square root in the bottom of your fraction, all you need to do is take the expression under the root, x plus 1, and set it greater than 0. Now usually with a square root we would set it greater than or equal to 0, but we can't have the denominator equal 0, so we leave that part out. So if you see the square root in the bottom, all you need to do is take the expression under the root and set it greater than 0 and solve. So in this case you subtract 1 from each side and you would get that x is greater than -1. So your domain would be all real numbers x greater than -1, or if you wanted to use interval notation, you would write parentheses -1, everything from -1 not including -1, all the way up to infinity. So either of these ways is fine to write your domain answer. Okay, if your square root is in the top of your fraction, you'll have two restrictions. The first one will be that what's under the square root has to be greater than or equal to 0. So x plus 1 greater than or equal to 0. And when you solve that by subtracting 1 from each side, -1, you get x greater than or equal to -1. The other restriction will come from the bottom, that the bottom can't be 0. So we have x squared minus 4 cannot equal 0. Now, to solve that, as before, you would have to factor. So you have x plus 2 times x minus 2 can't be 0. So I've rewritten that as a product of two factors. And when you solve each of them separately, set each of them not equal to 0, you get x cannot be -2, and x cannot be 2. Okay, so we have this restriction from the root, we have this restriction from the bottom. What you have to do in this case is take the intersection of the two. So if we think about this, x has to be greater than or equal to -1, which already takes care of -2. If x is greater than or equal to -1, we can't have -2 anyway, so you can ignore that one, throw it away. All you need to write for your domain, x greater than or equal to -1, except it cannot be 2, positive 2. And in interval notation, that would be that you can have everything from -1, including -1, up to 2, but not including 2. And then everything from 2, not including 2, up to infinity. So either of these notations is fine, and that's your answer for the domain. So I hope that was super fun finding the domain of your function. It's okay if you didn't have fun. You don't have to like math. But you can like my video, so...